Hey guys, I hope you're having a good day today. Today we're talking about L'Hopital's rule in indeterminate forms. So when we talk about indeterminate forms, we're talking about calculating limits. So let's say we just have limit as x approaches a. Suppose we're going to say f and g are functions, and we're just going to say some f of x over g of x, and let's say we get the answer to be 0 over 0, or maybe we get it to be infinity over infinity. This is an indeterminate form. Obviously, 0 over 0, we know that's undefined. So is infinity over infinity. We don't know what it is. We need to do something else to figure out what this limit is. So what we can do is use L'Hopital's rule. What L'Hopital's rule tells us, if we're calculating this limit, of f of x and g of x, and we get 0 over 0 or infinity over infinity, what we can do is take the derivative. Take the derivative of f and g, and maybe we will get an answer that's not 0 over 0 or infinity over infinity. If, for instance, we get 0 over 0 again, or infinity over infinity again, well, let's take the next derivative. And that process is continuing until we get a real answer, something that's determinate, not 0 over 0 or infinity over infinity. So let's do a quick example here. Let's say we're taking the limit as x approaches infinity of x squared over e to the x. Well, let's just see. This seems simple enough. Let's just plug in. Let's just see as x approaches infinity, and see what each of these functions do. As x squared goes to infinity, well, that goes to infinity. And as e to the x goes to infinity, that's infinity. Well, we've got an indeterminate form here, so according to L'Hopital's rule, we can take the derivative of the top and the derivative of the bottom. So what we will do, what's the derivative of x squared? That's just 2x. The derivative of e to the x is e to the x. So when we plug in, we notice when we let x go to infinity again, we get infinity over infinity. So we have to repeat the process again. So what's the derivative of 2x? That's just 2. And the derivative of e to the x is still e to the x. So when we plug limit as x approaches infinity of 2 is just 2. And the limit of e of x as x goes to infinity is infinity. Well, we don't have infinity over infinity anymore, so we need to figure out kind of what this is. 2 over infinity, just think of any number. So this is just 2 over a very, very large number. Very, very large number. This is increasing without bound, and this is just at 2. So ultimately, what this is going to be is 0. And actually, if you have any real number over infinity and you get a limit like this, let's say it's 137, this will still be 0. This is increasing without bound. This is not increasing or decreasing, just constant. Some constant over something that's increasing without bound as it approaches infinity. This will always be 0. So that's why 0 is our answer.